In today's session, we're going to continue on the path of having the correct mindset in the organization. And part of having the correct mindset is to be able to get breakthrough improvement in the organizational performance. So today's session is going to be on managing workflow. The paradigm that most companies have is the best way to manage workflow is to ensure that each operation is completed on time. So if there's multiple steps the work has to go through to complete, they try to schedule every workstation or every operation to make sure that that operation gets their work completed according to a schedule. So if we look at managing workflow, we know that there's value-added steps and that every workflow has variation. So every process has variation. So if we look at the variation, of course, each process is going to have different variation. So we can say, oh, the first step takes on average 6 hours, but it could take 4 and up to 8. The second step takes an average of 3 hours with a variation of 1. Third step, 8 hours with a variation of 3. So that totals up to 17 hours of time based on the average cycle time. We also have work in process in the system, and also the time that jobs sit in queue has variation. So the blue represents how much variability there is in the queue time. So if we look at the queue time, we see that 5 days on average, 3 days, 6 days, 5 days, so the average is 19 days. What most organizations do is they try to calculate based on ERP when they think the job is going to be at the first step, when they think it's going to be a job at the second step, when that job's going to be at the third step, and they have a schedule laid out for each operation that shows when the job should arrive. But of course, that's based on the average time, and we know that there's variation. So very rarely do the jobs show up according to the planned schedule. But what we know about statistics is statistical variation in a series average out. So what does that mean? So if our first operation takes 8 hours instead of 6, it's 2 hours over the average. The second operation takes 2 hours, which is normally 3 hours, so it's 1 hour under the average. And the last operation takes 6 hours instead of the average of 8, which is 2 hours. So now I look at the total, it's 16 hours. So the +2 -1 -2, instead of 17 hours, the job actually completes in 16 hours, even though we had large variation at the start. Also, if I look at the inventory, the same thing occurs. So the inventory in day 1, on average, it's 5 days for the supplier to deliver, and they delivered 3 days late. So now we're 3 days starting the job. But the queue times between the operations, we gain back a day because we can control the work in process. And now we finish in the 19 days. So when we look at it, the +3 -1 -1 -1 average out. But if you're trying to schedule this first operation to arrive starting on day 5, it starts 8 days late. So when we try to finite schedule, we're just in chaos all the time, recalculating and reissuing schedules for every workstation. What's the better way to manage is don't try to manage within the normal variation by finite scheduling, manage according to the total variation. So when we look at the total variation, we take the variation of all the processes, and because the statistical deviations average out, we can come up with a reliable production lead time. So in this case, we're going to say, okay, our reliable production lead time is 21 days. We're going to schedule shipping. We're going to back off those 21 days and say we should release on a certain date. And based on that, there's enough buffer in the system to absorb the statistical variations. And also, we implement a simple color code system. So the first 7 days that job is in production is green. The second 7 days is yellow. The third 7 days it's red. And the people in the workstations work according to the colors. They work on red orders first, then yellow, then green. And just managing this way with a reliable production lead time and a color priority will bring the reliability of the system up above 90% easily, and with a little bit of work above 95%. So that's our session for today. We don't want to manage the workflow according to every operation. We want to manage the workflow according to the total variation in the system and let the variability average out, and so that we can be predictable in the performance of the system. In next week's session, we're going to challenge the mindset of the best way to service the customer is to hold more inventory.